Just did the step of point 1 here for exercise 1 for Euler's method by hand, and now I want to show you how to program this so that you can take smaller and smaller step and you can make the errors smaller and smaller, and therefore get closer and closer to the actual resemblance of the solution function. So let's go over to Matlab. And in here, the first thing I'm going to do is I'm going to clear all variables, clear all. Then what I'm going to do is I'm going to, let's see. The first thing I want to do is I want to define the initial conditions. So let's say that x1, and I'm going to show you why I put this parenthesis here, that x1, they said, was equal to, what was it equal to? Let's see, x1 was equal to 1. That was our first x, and y1 was what? Or y1 was equal to 5. So those are my initial conditions. Then what I want to do is I want to define a counter, so let's say n, and we'll start it at 1. Then I think, and we'll see if this works or if I'm forgetting something else, I'm going to start a while loop. Defining a while loop, because I want something to happen over and over again. So to define a while loop, you have while, and then you have a condition that's going to allow the program to say if it needs to execute that while loop or not. And I'm going to say, while x of n is less than 1.5, because we're trying to get to, 1.2, we're trying to get to 1.2. And then to end the loop, you just write end. Now you need to tell it to do something inside the loop in order to have this going and going and going. So what I'm going to do now is I'm going to say, well, what do I want to do? Well, remember what we did over here on Teams. Sorry, not on Teams, on OneNote. I have my two initial conditions. This is x1 and y1 in Matlab, because you can't start from an index of 0. And then I want to take those two and plug them into this. So I notice here that I need to have an h, and I need to define that h. So let me define that h outside here, defining the step h, and that's going to be 0.1 for this one. And then here, I want to take these things and put them into this. So let's do that. What are we going to have? We're going to have 2 times x minus 3 times y plus 1. That was our formula, right? Now, I don't want any x. I want the x that we are entering with. And we're starting, so this is x of n, and n is 1, so we're starting with x1 and y1. But I want to keep it in general terms, so I'll put x sub n, y sub n here. Now, what is this going to be equal to? Well, this is going to be equal to my y, and my y is going to be equal to, is it going to be my yn? No, this is my yn. It's going to be equal to x, it's going to be equal to n plus 1. So if this was my y1, my y2 is going to be this stuff that needs to be multiplied, though, by h, don't forget. And that comes from this right here. We did this part. Now we need to multiplied by h. So my h is defined outside, so I just write that. And I don't want it to output, so I put a semicolon. And actually, let's output it first to see if it works. So here I'm going to defining the new y. And then what do we do? Well, then I want to find a new x. So let's first define, update the counter, and we'll have n is equal to n plus 1, which means I'm going to have an n of 1 here. I'm going to get in here. This is going to be x of 1, which is going to be 1, which is going to be less than 1.2, which means I'm going to get into this loop, and then I'm going to take h, which is defined over here as 0.1, and multiply it by 2 times x of n, which is still 1, so it's still this value over here, minus y of n, which is this value over here. And then I'm going to take this, and we need to add the y of n here. And that comes from this, the old y. Then we define the new y. And then we say, okay, now take my n, which was 1, add 1 to it. Now n becomes 2. And now I'm going to say, finding the next x, which is really going to be just x sub n. Now this n, remember, is 2. So now we're going to say x of 2 is equal to x, the previous x, in this case x sub 1, plus h, because we're just incrementing by h. And we don't want any of these to output, but we want this to output. And then once we have that, what's going to happen? Well, we're going to go back here, because this is going to do a loop until this doesn't work anymore, until this is not true anymore. So then we have x sub 2, and it's to still be less than 1.2, because x sub 2 is going to be this one, which is 1.1. And then it's going to take the previous y, which should be in this case this one right here, and it's going to add it to the previous y. It's going to add it to the new step, and we're going to get the new y right here, and this is going to repeat until this is not true anymore. And then what we want to do, we'd like to plot scatter. We'd like to have a scatter plot of our x and y, our x and y. And let's see how this works. Plotting the results, and that should give us a feel for what the solution looks like. So let's press Control Enter. Let's see if we did things correctly. Here it's outputting. And right here we can see that we have 3 solutions for y, which are the ones that we were getting before, right? When we did it by hand, we got 5, 3.8, and 2.98. 5, 3.8, and 2.98. And this is from the previous iteration, because it keeps on adding. Every time it gets a new n, it adds it to the previous one, and you get a big vector 1 by 2. And then it plots x's and y's. This is my x-axis. This is my y-axis. So I think I can label the x right here with the text, and I can say that this is my x, and label the y with the text, and I can say that this is my y. And I don't want the whole thing to repeat, so I'll just put a section break, because these are all already saved in the workspace. And here we have our x's and our y's. Okay. So I hope this was useful for you. Now we can change the step. So say we want 0.5, we're going to get a little more values here, and we're going to get something that is closer to the actual solution. So let's press Control Enter here. I'm going to get more values here, and you see we're getting more points, so we're getting more resolution here. Yeah, you can see it here. Now, what if we do 0.05? Then we're going to get, look at how many values. We couldn't be doing this by hand 42 times. However, now we get something that is a little bit better. So this is a pretty powerful method, even though we might resort to other methods to be even more precise. I hope this was useful, and I'll see you next time.